Hey everyone, I hope you're doing good. Welcome back. So in this video we are going to explore another program from the ICSE computer board paper. The program is on special number. You have to input a number and print whether it's special or not. So the special number is such a number whose factorial of the digits, the sum of the factorial of the digits would be equals to the original number. For example, 145. 1 factorial plus 4 factorial plus 5 factorial gives us 145. So it's a special number. So let's now check how we are doing. So before progressing to the problem, let's first break this problem into two parts. The repetitive task what we are doing is calculating the factorial of a number. If we are taking n as an input, we are returning the factorial of n. So this is a block that we are going to execute. And another block is we are breaking the program into two parts. Okay. So the block diagram would be like this only. You are taking an input n, we are returning the factorial. What is a factorial? A factorial is the product of the numbers from that number to 1. Suppose 5 factorial. 5 factorial means 1 into 2 into 3 into 4 into 5. That's 120. Okay. So that we have to write here. We have to write a method. Okay. Now the second part of the program is we have to take a number as an input and then we have to break its digits and calculate the factorial of each digit, and we have to sum up that, and we have to check whether it is a special number or not. So this would be the second part, to check whether it's a special or not special. So we are going to check that. So special checking method, special number checking method, and another method is to calculate the factorial of digits. Now we would do the method call and utilize the method inside a for loop, a while loop also we can use. So this is the basic structure of the program. Now let's deep dive into the implementation. I would be taking a console input. Now in this program I am going to use scanner class. So import java.util.scanner. Okay, so the scanner class resides in which package? In util package. This is a very common short question in ICSE board computer paper. So util package contains the scanner. So we have to write the import java.util.scanner. Now give a class name. Since now no class name is mentioned in the question, you can use any of them, but give a meaningful name. Okay. Now the next task would be to write that method that returns the factorial. Now I am giving the name of the method as fact. What would be the task of this method? To input a number and find the factorial and print the factorial. To find the factorial, what we have to do? We have to multiply 1 with 2 with 3 dot up to that number. So basically we have to generate these numbers, right? In order to generate those numbers, what we have to do? We have to run a for loop, and to calculate the factorial we have to take a variable, that is the f, factorial variable. Now inside the for loop we would multiply that. So the starting value is 1. It is executing up to n. I smaller than equals to n, I plus plus, and f equals to f into I, and then we are returning the value of f as an output of this method. So what this logic does? So it is initializing f with 1, and then we are running the loop from I equals to 1 up to that number. For example, we have that n input as 5. Okay, we are checking the dry run. Now if n is equals to 5, when the first time the program executes, the value of f would be 1. I value is 1, starting with 1. The next task would be checking the condition. 1 is smaller than equals to 5. Yes, it would enter the loop. Till the condition is true, the loop body would execute. Once the loop condition is false, the loop will not execute. So what is in the loop body? F equals to f into I. F is being overridden with the value that is in the right hand side of the equals to operator, the assignment operator. So we have f into I. F is 1, 1 into 1. So this is the first time the loop is executing and f is 1. Okay. Now next time I increments with 1. I plus plus means I equals to I plus 1. So i's value is incrementing to 2. Now 2 is smaller than equals to 5 since 5 n is 5. 2 is smaller than equals to 5. Yes, it's true. The loop body would execute. F equals to f into I. What is the value of f? Value of f is 1. 1 into 2 is 2. So now the value of f becomes 2. Okay. Now the value of I again increments with 2 plus 1 is equals to 3. Now the value of I is 3. Next step would be checking the condition. Every time whenever the loop body would execute, before that the condition is being checked. If it is true, loop body would execute. If it is false, loop body would not execute. Now 3 is smaller than equals to 5. Yes, it's true. The loop body would execute. Yes. So f equals to f into I. F value is 2. The value, updated value is 2. Every time the value of f is getting updated, in every iteration or every loop, the value of f is getting updated. The updated value is 2. Now 2 into 3, it will become 6. So it would become now 2 into 3, 6. So see what is happening in the background. 1 into 2 into 3 is being done. Right? Now i's value would increment to 4 because I plus plus means I equals to I plus 1 here. Then after that 4 is smaller than equals to 5. Yes, it's true. Loop body would execute. Yes. Loop body is f equals to f into I. So 6 into 4. Now the value of f would be 6 into 4, 24. So factorial is becoming 24 because f into 4 we have done, right? This is achieved. Again, i's value would be incrementing to 5 now. 5 is smaller than equals to 5. Yes, it's true. Then the body of the loop would execute. 24 into 5 would be stored inside f, that is 120. So we are doing the factorial here. Again, the value of 5 would increment it to 6, right? Because I plus plus is there, obviously it would increment. But will the body of the loop execute? Let's find out. 6 is smaller than equals to 5. 6, i's value is 6. Smaller than equals to 5? No. It's a clear no. Means false. The loop is false. The condition of the loop is false, means the body of the loop would not execute. It would jump out of the loop. Outside the loop we have a return statement. So we have to return the value of f. The value of f is 120. So this method will return us 120 if we give 5 here. So it is acting as a black box. If we enter a number, we would get the factorial. Okay. So that part we have achieved. So factorial part is done. Next we would implement the next method, the next part of the program where we take the input of the number and break those digits inside that number and call the fact method. If you haven't written, please take a screenshot or write the code. I will move over to the next part. Now we are going to write the next method, that is the taking the input of the method. So next we are going to take the input with the help of scanner class. So we have to take the scanner object, scanner sc equals to new scanner, system.in. So scanner object takes a system.in object. Okay. Now we would take the number as input. So we have to give a prompt to the user that please enter a number. Now int in equals to, rather take num equals to sc.nextInt. So in scanner class we have this nextInt method which reads the integer from the console window and returns as an integer and directly it stores in the num variable. Now we are done with the number input. Now we have to break that into digits. Suppose num is 145 given input from the user. So we have to break the digits, right? We have to crop the digits. First we have to chop out 5, then we have to chop out 4, then we have to chop out 1. Then we have to calculate the factorials, the 5 factorial, then the 4 factorial, then the 1 factorial, and then we have to sum them up. So this is our task, right? In order to chop the digits, we have to utilize a while loop. But before that, let us back up the number the number what we have taken as input, let's back up that inside dup variable. I am taking as a variable, so you can take any name. Now next what we are doing, we are going to sum up this factorial, so I am taking a sum variable also. Now we are entering inside the while loop. Let's write it here. I would require some space. While this dup variable is greater than 0, up to that the loop would execute. In the loop what we are doing, we are dividing that dup with the 10 and we are taking the remainder. And in the sum variable what we are doing, we are adding the factorial of that remainder we are getting in the previous step. And we are also updating the dup with the help of quotient on dividing it with 10. Now what this loop is doing? Suppose the number is 145 in the beginning. 145 greater than 0? Yes. Now we would divide 145 with 10. What is the quotient? The quotient is 14 and the remainder is 5, right? This is the quotient q and this is the remainder 5. Whenever we divide, please listen to this line, whatever I am saying now, very carefully. Whenever we divide any number with 10, we get the ones place digit as the remainder. Take any number, let it be 123. If we divide that with 10, we would get the ones place digit in the remainder always. So dividing with 10 and getting the remainder is only way of chopping out digits from the back. Okay? So that funda, that mathematics we are using. We are dividing the number with 10 and then we are taking that remainder r. Now that r, that digit which we have extracted, we are calculating the factorial. That factorial means we are summing them up in a sum variable. So we are summing it up. And then since in the next time we want 14, right? Now 14 would be divided by 10, we would get 4 as the ones place digit, because next time we are interested in extracting 4. So we have to divide 14 with 10 now. So that way we can get the remainder as 4. Then we would find the 4 factorial and add them up. So in order to get 14 from 145, we should get 14. How we would get 14? If we replace dup with the quotient, then we would get, right? The quotient is only the remaining part. Excluding the remainder, what we have here, this is the quotient. This is the quotient, this is the remainder. So this is the quotient, 1 is quotient, 4 is remainder. In this step, 1 is the quotient. 1 is the remainder, sorry. Then last step 1 would be the remainder. So if we replace the dup with the quotient, we would achieve that. Now this loop would repeatedly execute and find out, extract the digit, find the factorial and sum it up. Again it would shorten the digit. Again it would check whether it's greater than 0, 14 greater than 0, yes. Then again 14 percentage 10, we would get the 4 as remainder and 4 factorial would be added up. Whenever we are writing this fact and then we are doing the method call, this is the method call. Whatever parameter we are giving, that is being sent to that method that we wrote previously, the fact method, factorial method. It's taking an integer n and it is finding the factorial and returning that. That return value was an integer, that integer being summed up in some variable. So repeatedly this would occur and we would get this, we would achieve this. Calculate the sum of the factorial of each digit of that number. Now the only task that is left is check whether this sum, what we have achieved outside the loop, we have to check whether that sum is equals to original number num or not. If it is equal, then it is a special number. So system out dot print ln, it's a special number. Else it's not a special number. System out dot print ln, not special number. Okay. Class and function ends here. So this was the program of scanner this was the program. So this was the program for the special number. We are calculating the sum of the factorial of each digit with the help of method call, and then we are checking that sum is equals to the original number or not. Then if it's equal, we are printing special number, otherwise we are printing not special number. Can you say now why we took this dup if we had this num variable, right, the input number, but we took dup? Because see, dup greater than 0 and dup is always getting truncated by the quotient. It is getting updated. If we had taken this variable here, num variable, we would have changed the original number, because at the end of the loop the value of dup would be 0. The value of dup would become 0, because when the last one is there, if we divide any single digit number with 10, then the remainder is always that number and the quotient is 0. So dup would become 0. So that is why dup would get changed, and so we won't get that number back. We won't be able to check this condition. So that's why we have to take our backup variable dup and use that. Okay, that was the program. Now we are going to see the implementation in the next part.